Hi all, very good morning. So thank you so much for joining the session. So today's webinar is on basically outlier detection using isolation forest. Uh, so before even starting the session, right guys, so the speaker of the session is Kalpana. She works as a data scientist in Rubik's and she will be giving us a detailed idea about the isolation forest. Right. So in our previous webinars, which was done on basically feature engineering side, where we have discussed about how to handle missing values, right? How to handle the outliers, right? So now this is the third webinar on the same series, that is feature engineering.
So today's session is going to be about outlier detection using some automatic outlier detection method, which is isolation forest. So basically, this session requires you to have some basic knowledge of machine learning algorithms, especially on decision tree and random forest. So if you are not aware of those two algorithms, I request you to have get some knowledge about that. So now today let us see about, you have background noise. Just a moment. Hope it's clear now. Okay. So today we are going to discuss about the outlier detection method, okay, which is isolation forest. Okay. So first let us discuss about what is an outlier. So I hope you have idea about outlier. All right. So what is an outlier? Can you tell me what is an outlier in the data set? So I want it to be an interactive session. Okay. So you can put your inputs. You can share it in chat. Yes, Paras. Anomaly that causes error inaccuracy. Mahesh is telling values outside the normal distribution. Vasavaraj tells the values for okay, it means far away from mean value. Data which is extreme. Okay, so you're all close to that. So we can outlier is a data point beyond the average data point, Sapna is telling. Okay, yes, correct. So an outlier is a data point which is abnormal or which is far away from the other data points, right? It can be called as an anomalous point, okay, which is different from rest of the data points, right? So when I say outlier detection, it is nothing but it is a task of finding the anomalous point, okay, which is far from the other data points, right? So there are several techniques. So you might have used several other techniques for detecting the outlier, right? So you can visualize the outliers, right? So using some visualization tools, you can visualize the outliers like box plot or histogram or scatter plot, right? And you can use some statistical tools like z-score or IQR range, or even some machine learning algorithms, like db scan. So there are several ways to identify the or to detect the outliers. Okay. So when I say detecting the outliers, sometimes it could be very challenging task. Okay. So sometimes it is not easy to identify the proper outliers. Hence, data scientists have come up with a few automatic outlier detection methods, okay, which makes your task easier. Okay. So we have a few automatic methods for detecting the outliers, okay, like isolation forest or one class SVM algorithm or elliptical envelope. So we have few outlier detection methods. So we are going to discuss about one of the automatic outlier detection method or technique, which is isolation forest. Hope my screen is visible. Just give me a confirmation. Okay. Okay, thank you. So let's see what is isolation forest and how it works. Okay. So as I told, this is one of the automatic outlier detection method, right? So this isolation forest is a machine learning algorithm which was introduced in 2008, and it became available in scikit-learn in 2016. Okay, so it is an ensemble technique. So what is ensemble technique? So I hope you have idea about ensemble techniques, right? Just like random forest, bagging, right? So in ensemble technique, it combines multiple of models, right, to do the final prediction. So this isolation forest is one of the ensemble technique, and it is just like your random forest. You can also say that it is a variation of random forest, okay? But the ultimate aim of using this isolation forest is for identifying the outliers. Okay, so rather than doing the profiling the data points, this algorithm is used to identify the outliers. Okay, so we will see how it identifies the outliers. Okay, so basically this is an unsupervised setting for anomaly detection. Okay, so this is a variation of random forest which can be used in an unsupervised setting. Okay, basically we don't have labels here, right? We don't tell which data point is outlier or which is not. Okay, so there are no labels. So this is a part of unsupervised learning technique. Okay, so we will so you know how random forest basically works, right? So in random forest, the entire data set is split into samples, several subsets, and that will be given to the decision trees. So random forest basically combines the decision trees, right? So this decision tree will work on the subset. So this will be your data set, the whole data set, and where the random forest is going to do the row sampling and feature sampling. Okay, so it is going to randomly select some samples or and some features and will give it to this decision tree. The same way here again it is going to select some samples and it is going to give it to the next decision tree. Like this, it is going to combine several decision trees, right? And it gives a subset of the data to each decision tree. So here each decision tree will get trained on the data and it is going to do the prediction, right? So you will get the output here, which will be finally combined, okay? And based on the majority voting, the final output will be taken. This is how a random forest works, right? So in similar way, this isolation forest is also going to combine multiple decision trees. Okay, but it is going to identify the outliers in each model. Okay, so it will take so it is built on the basis of decision trees. Okay, so this is the base estimator, the base model for isolation forest. Okay, so how it works? So it basically isolates each observation or each data point I'm sorry for my handwriting. I hope you can understand. So it isolates each data point by randomly selecting a feature. Okay, and then again it randomly selects the split value. I'll explain you with the example, then you will understand. So this split value will be selected randomly between a maximum and the minimum value of the feature. Of the selected feature. Okay. So basically what isolation forest will do is it is going to isolate each and every data point in your data set by randomly selecting a feature, and it will take that feature to do the split. Okay, and the split will be done by choosing some value randomly between the maximum and minimum value of the selected feature. Okay, so what is the ultimate aim of this isolation forest is that it is going to isolate, or it is going to separate each data point from the others. Okay, and it is going to check the path length of each data point to get itself isolated. Okay, so the function of this isolation forest is going to be isolating each data point from the data set. Okay, and how it is going to differentiate an outlier from the other data points. Okay, for that it is going to check the path length taken by each data point. Okay, so let us see one example and then you will understand. So till here, is it clear? So let me just give you a small and simple example. So let's say we have a data set. So I have a data set here. Okay, so it is how much second each person can hold the breath. Okay, so I have some names here. And let's say one person can hold the breath for 50 seconds. Okay, and these are the seconds that each person can hold the breath. Some values are there. Okay, now this is the data set given to the isolation forest. Okay, so now the isolation forest will get trained on this. So basically it splits the data set as it does in the random forest. So basically the decision forest will split your data set into a tree-like structure, right? The same thing here it will be done. So let us see how it is going to do. So it will do the split based on some value. Okay, and this value will be taken randomly. Okay, we will not know which value will be taken. Okay, so randomly it is going to take, let's say, seconds, second greater than 100. Okay, so whichever observation has more than 100 seconds, that will be splitted here, that will be coming here. So in this data set, we have only one observation which is greater than 100, right? So that data point will come here, and here all other data points will be coming here. Right? So again, here it is going to do the split. Okay, so let us, again it will randomly select some value. So let's say it should be greater than 51. So whatever points that are greater than 51 will come here. So we will have 70, we will have 60, 65, 55, right? All this will be here. And the data points which has less than 51 will be here. Okay, so again the split will happen here until each data point is isolated. So if you notice here, this particular data point is isolated, right? And here, until each data point is getting isolated, it is going to split in a similar way. Okay, so here with some condition, let's say it is splitting these two data points. Okay, and here again with some condition, it is doing the split. So again here, until each data point is separated, it is going to split. Okay, so this is called as the terminal nodes. This we call it as terminal nodes. Terminal node. So this is a terminal node, this is a terminal node, right? And this is a terminal node. So the number of terminal nodes will be the number of data points you have in your data set. So until each data point is isolated, this isolation forest is going to split each data point. It is going to split this subset to get each data point separately. Okay, so now how it is going to identify the outliers? So if you see here, for this particular data point, this is the path length. Okay, so let us say for this data point, what is the path length we have? So from here it goes here and again here. This is the path length taken by this particular data point, right? So the isolation forest is going to see which data point is first isolated, which has the shorter path length. So that data point will be an outlier. So in this case, if you see in this data set, this particular value is far away from the other data points, right? And if you see here in the split, this is the first data point which is getting isolated. So this particular point will be an outlier. Okay, so this isolation forest is going to see which data point is quickly isolated. And which has short path length. This is the path length. So this particular data point has shorter path length, right? So this particular, and it also quickly gets isolated. So this data point is an outlier in this data set. Okay, but we cannot take all this. So this will be done randomly. The feature will be selected randomly. So here in this case, we have only one feature. But imagine when you have more number of features, the feature selection will be done randomly. Okay. So we are not going to decide on this. Okay. So it will be done randomly. So isolation forest, going to isolate each observation by randomly selecting a feature. Okay. And then again, it is going to randomly select the split value. Okay. And with that, it is going to isolate each data point. So unless each data point is isolated, it is going to do the split. Okay. And then it will find the data point which is quickly getting isolated, and it will also check the path length. So whichever has the short path length, that will be an outlier. So outlier will always be quickly isolated. Okay. So this algorithm is very easy to use. Okay, it easily identifies the outliers. So understood till here how this isolation forest works? Path length is nothing but, see, here, if you see, it takes only one branch, right? And if you see here, how many branches it is taking? Here one branch, here one branch, here. So this takes 3 splits, okay, or 2 splits for this particular point. Yes, it is taking 3 split, 1, 2, and 3. So the number of split for this 55 is 3. And here, for this particular data point, only 1 split was required, right? So always the number of split will be less for outlier. Okay. Okay. Yes, Paras. It's like a guinea. But here we are going to identify. So guinea is used to select the important the feature for doing the split, the proper feature for doing the split, right? But here this is used to identify the outlier. So we will check how many number of split is considered, how many number of split is taken by each data point to get isolated. Okay, so this is how the isolation forest works. But just by checking the path length or the number of splits, we cannot decide a data point to be an outlier. Okay, so basically we need a valid point to consider a data point as an outlier, right? So for that, it uses the score function, anomaly score function. So this function will calculate the score for each data point, okay, based on the path length. Okay, so we have a formula for this. So I'll tell you. So till here, is it clear? Yes. See, it is not just like your decision tree. Okay. Only thing here, the similarities between the random forest and the isolation forest is that both are going to combine multiple decision trees. Okay. But here the fundamental idea of using isolation forest is only for detecting the outliers. Okay, so whichever data point is quickly getting isolated, okay, and whichever has a short path length, so that particular data point will be identified as the outlier. Okay, yeah. So let us discuss about the anomaly score function, which is basically used by the isolation forest. So the formula for this is so this is a score. So score of any data point, okay, with the number of data number of observations will be equal to 2 to the power of minus expected average path length divided by average path length of all the nodes. Okay, so here S is the score, expected H of X will be the average path length taken by X, okay, taken by this data point, and C of N is the average path length of every terminal nodes. Okay, so first let me explain you how an outlier will be isolated. So let's say we have a data set like this, and there is one particular outlier here. So when this data set is given to the isolation forest, it is going to do the split randomly. Okay, so let us say first split happens somewhere here. Okay, the second split happens here. The third split happens somewhere here. So like this, until each data point is getting isolated, okay, it is going to split. So let us stop here. Let us first see how this outlier is isolated. So here, this was the first split, right? So it can happen in any way, okay? Because it is going to randomly select the feature and randomly going to select the split value. So it can happen in any way, okay? So let us say one decision tree is doing the split this way to isolate this particular point. Okay, so this is the first split made by the decision tree, and this is the second split. So in two splits, it was able to isolate this particular point. So number of splits here was 2 to isolate this particular point. Now let us say if it has to isolate this point, okay, or somewhere, let's take a point which is let's say for this particular point, how the split can happen. So how the split can happen here? Let's say for this particular data point, okay? So it can happen this way. So like this, many number of split will be required to isolate this particular point. Okay. So if you see the number of split taken for this point and this point has lot of difference, right? So how many splits have been taken, considered here, taken here to isolate this particular point? We have 1, 2, 3, 4, 5, 6, 7, 8. So here the number of split is 8, right? So this outlier point will always quickly gets isolated from the other data points. Okay, since it is far away from the other data points, okay, it is dissimilar point, so it gets easily isolated with less number of splits. But whereas for any inlier or any normal data point, it takes several number of splits compared to this outlier point. Okay, so here the number of split will be more compared to this particular point. Okay, so the isolation forest will take many number of splits in case of an inlier data point. Okay, so for this the path length will be more. For this the path length will be less. Okay, so using score function, anomaly score function, this isolation forest will check the score of each data point, and the score will be calculated by the average path length taken by one data point, the particular data point divided by average path length of every data points. Okay, so this is the formula to calculate the score function. Okay, 2 to the power of minus expected h of x is nothing but this h of x is the path length taken by this x, and expected h of x will be the average path length taken by the x. So when I say average, then it should have more number of splits here, right, for this particular data point. So how can I get the average path length? So as I told, it is going to use multiple decision trees, right? So I was telling about only one decision tree here. And what about the other decision trees? Let us say we have 100 base estimators, 100 decision trees. Okay, we are going to combine 100 decision trees. For one decision tree, we have the number of split as 2 for this particular data point. So what about the other decision trees? So you will be having many number of, means 100 number of decision trees, right? You will have multiple decision trees like this. Okay, let's say 100. Since I have given 100 base estimators, so while giving this, while initializing the algorithm, I can specify how many base estimators I need. Okay, so if I give 100, it is going to consider 100 decision trees. This will be first decision tree, this will be the second, like this. It will have 100 decision trees. Okay, so for each in each decision tree, it is going to isolate the data points. Okay, it is going to select the feature randomly. Here one feature will be selected, here it can take a different feature, here it can take a different feature and do the split. Okay, so like this it will take different features. Okay, and each node, while splitting, the values might change because everything here is, it's done randomly. Okay, so for this particular point, in first decision tree, it might take single split, but in second decision tree, it might take two splits. Okay, in the next one, it might take 2 or 3 or 1 split for getting isolated. Okay, so the the number of splits in each decision tree for each data point will be different, because each decision tree is going to pick the features randomly, going to do the split randomly, so it will differ. Okay, so now for first decision tree, for this particular data point, the number of splits was 2. Okay, and let's say here the number of split for isolating this data point was this data point. I'm referring to the outlier. Okay, so for this it requires 2 splits. Okay, similarly here let us say it requires 2 or 3 splits. Okay, so the number of split, okay, in each decision tree is differing for a single data point. Okay, now it will see how many splits have been taken for each data point. Okay, so it will get the average path length, okay, taken by each data point. It is going to calculate the average. So here, when one split, okay, let us say in one split we got the outlier getting isolated, and in the second one it took 2 splits, and in the third decision tree, let's say we got 3 splits. Okay, in 3 splits we got the data point isolated, and like this it is going to see the number of splits taken in each decision tree, and with these values it is going to take the average path length. Okay, so how it will take the average path length? It is going to add all this and going to divide it with 100. So we have 100 decision trees. So we will get 100 number of splits in each decision tree for each data point. Right? So if I take one particular data point, let us say this as x. So the expected h of x will be the average path length taken by this x. Let us say after getting the taking the average value I got it as 2. Okay, so this will be taken here. Okay, 2. Okay, to the power of expected h of x will be 2. Okay, for this particular data point, but for every data point it will calculate the average path length. Okay, and this C of n is the average path length of every terminal node. Okay, of all terminal nodes. What is terminal node? Here if you see, each point is isolated, right? This is a terminal node. This is a terminal node. So how many number of terminal nodes we will have? The number of observations or number of data points in our data set, those many number of terminal nodes we will have. Okay, so it is going to calculate the average path length of all the terminal nodes. Okay, and it will compare with all the decision trees. It will take the average of that. Okay, by computing these values, it is going to calculate the score for each data point. Okay, is it clear? So based on the score only, it is going to decide which point is an outlier. Okay, so if the score, let me clear this. So if the score is closer to 1, then that will be an outlier. Okay, and if the value, if the score is closer to, let's say, less than 0.5, okay, so that will be, let's say it is closer to 0, that will be a normal data point. No, it's X is each data point I'm referring to. Okay, in the data set. Okay, so let's say if I want to calculate the average score for, anomaly score for this data point. Now this will be the X. If I want to calculate the anomaly score for this data point, this I'll take it as S. So X refers to the data point in your data set. Any particular point you take, that will be X in your formula. Yes, you will have the recording. Yeah, you have to request it, request for that, so you will get it. Okay. So you cannot always tell that outlier will be based on only one feature or one column. Okay, sometimes when combining the features, we can get the outlier. Okay, when you combine multiple features, you will get the outliers. So let's say we have X, we have X1, X2 in our data set. Okay, so it's not that sometimes only with one feature we will have the outlier. Sometimes all the data points here may not be an outlier, but when you combine these two, okay, that might create an outlier. When you combine these values, that might create an outlier. Okay, so that kind of outlier is called as multivariate outlier. Which means that when you consider single feature, you may not find any outliers there. Okay, but when you combine two or more features, and if you see any outlier, then that outlier is called as multivariate outlier. Okay, so isolation forest can be used for both detecting the univariate. So in this case, we had only one feature, one independent feature. Okay, and that was having an outlier. Okay, so it can be used for detecting both univariate and multivariate outlier. Implementation will be the same way. Okay, fine. Is it clear? Okay, so we are not going to calculate the score manually. We have the Python implementation. For that, we have function in Python which is going to calculate the score and which is going to classify the data points as outlier or a normal data point by giving a score. Okay. So is it clear here till now? So we will see the implementation where you can see how the isolation forest works. Okay, based on how based on the score, how we can decide whether a data point is an outlier or a normal data point. Okay, fine. So let us go to the implementation part and let's see. So let me share my screen. So here we have taken a data set, a small data set. Okay, and here we are only going to identify the outliers. Okay, we are not going to do any prediction or any classification here as we do with other algorithms. So basically, we use isolation forest only for detecting the outliers. Okay, so we are not going to build any model here. We will just see how this algorithm is going to detect the outliers. Okay, so first let us, so here I have taken a data set which is marks.csv. Okay, so to this notebook and the data set with you, but you can take any data set and you can just implement this. Okay, so this is a small data set. So let us import all the required libraries. So here I'm going to load the data set using read_csv from pandas. So I have loaded the data set. So if you see, this is the, let me show you the full data set. So in this data set, we have the student ID and the marks scored by the student. Okay. So if you notice here, we have two observations, which has a value far away from the other data points, right? It's an abnormal data point. So this particular data point and this particular data point has a values in marks, which is significantly differing from the other data points, right? So these are the two outliers we have, but let us see how. So this is a simple data set, so you are able to identify the outlier here. But when you work with a huge data set, you may not be able to identify it, right? You have to go for other techniques to detect the outliers, right? So let us. So you have to, so let's load the data set and let us visualize it using box plot. So as you know, student ID is a unique value, right? We will not take that for any analysis. So here I'm, visualizing this marks feature. Okay. So if this box plot shows that we have two outliers, right? So this is one way of identifying the outliers, but let us see how to use isolation forest to identify or to detect the outlier. So here we have to, as I said, this is an ensemble technique, right? This is one of the ensemble technique. So we have to import that from ensemble, just like the random forest. Okay. So from sklearn library, under ensemble module, we have this isolation forest. So we are going to import it. Okay, so now you can initialize the model. Okay, so I create an object for the model. Okay, so here I'm going to give the values for the important parameters. So here we have more parameters are there, but here the important parameters are number of estimators and a parameter called contamination. So basically, what are parameters? The parameters can control your model, right? It constructs the model, okay, in such a way that you want. So here I want to build a model with 100 estimators, okay, 100 base estimators. Basically, these are going to be the decision forest, sorry, decision trees, right? So 100 number of decision trees I'm going to have, and contamination value is nothing but the proportion of outliers that you can have in your data set. Okay, so you have to give this. If you don't, if you can't give, if you can't mention how much outlier, how much proportion or ratio of outlier I can have in the data set, then you can just give it as auto. Okay, let me show you the official website of this isolation forest. There you will get the details of all the parameters. So basically, whenever you learn any algorithm or any concept, always refer to the official site of that technique. Okay, so this is the official documentation of this SK for isolation forest. So if you want to know about the parameters and all, so here you will get the details. You will get the entire information of isolation forest. Okay, so what are the parameters we have and what each parameter is used for. Okay. So this contamination and number of estimators are the important parameters. So here we are just going to use these two parameters. Okay. So contamination will tell you how much ratio of outlier can be considered in the data set. Though we may not know. Okay, initially it's like a trial and error basis only. You have to check whether you are able to achieve the number of outliers, okay, from your data set. So this gives the ratio or the proportion of outliers. Okay, you have to give value in between 0 to 0.5. Okay, so when you give 0.03, which means that 3%. Okay, so outliers will always be, we always assume that outliers will be few only, right? And it will be far from the other data points, right? This we always have an assumption on the outliers, right? So it will be, very few in numbers, isn't it? So the values you can pass is in between 0 to 0.5. So when I say 0.5, it is 50%. Okay, if I say 0.1, it is 10%. Okay, if I say 0.01, it is 1%. So here I am telling to consider 3% from your data, from the data set. Okay, so let us see if I pass this, whether I'm able to get the outliers. Okay, all the outliers, whether I'm able to get it or not. So we are using random state. So this will set the random state. Okay, so each time when I execute, the values will not change, right? So since here it randomly picks the features, okay, we use this parameter. So you can pass any number here and check how your model is performing. So these two parameters I'm using, these are the main parameters. So here I'm telling 100 decision trees and 3% of outliers has to be deducted from the data set. You can also change this and see how you're getting. Okay. So let us initialize the model. Okay, so this particular statement is going to initialize the model. Okay, and I'm going to use fit function to train the model. Okay, so in fit function, I have to pass the data to my model, and my model will get trained with the data that I am passing. Okay, so now the model has got trained with the data. So now let us calculate the score. So as I told, it is going to use the anomaly score function to get the score for each data point. Okay, so there is a function called decision underscore function, which is going to return you the anomaly score of each data point. Okay, so I have taken that into a new label in my data frame. Okay, so let us see what is the score that we have got for each data point. So how many number of records I have? I have 50 records, and for each record, each observation, I have got the score using this decision underscore function. So basically the formula which I told you will be implemented in this function, and it will calculate the score. Okay, so if you see here, for this particular data point, you have the negative value, negative score. And for this particular data point, we have the negative score. So we have got the score now. And let us allow the model to predict whether each data point is an outlier or not. Okay. So based on this score, it is going to see the point whether it is an outlier or not. So using predict function, I'm going to check which point is going to be an outlier. Okay. So again, this also I'm going to store in a new label, anomaly. So in predict function, I'm passing the data that has to be classified, right? So I'm interested only to know which data point has -1 as score. So first let me show you how the prediction is done. So based on the given score, the model is identifying each data point as the outlier and a normal data point. So when you have 1, when it returns 1, this data point will be taken as the normal data point. Okay. If the output returned as 1, this will be considered as a normal data point. And if any data point has identified as -1, then this will be taken as the abnormal data point or an outlier. Okay, so this predict function is going to return the value as -1 or 1. So 1 will be considered as the normal data point and -1 will be taken as the abnormal data point. Okay. So now, based on the contamination parameter, it has identified 2 outliers. Okay, let me change it to a different value. Let us say I give it as 5%, or let us increase it. Let me give it as 10%. Okay, I'm telling that 10% of data points can be taken as the outlier in the data set. Okay, so now let us train the model, and let me check the score now. So if you see, we have more number of data points with a negative score, right? Let us do the prediction. Okay, so if you see here, so what it is basically trying, when you increase the proportion, it will check which other data points are away from the normal points. Okay, so let us say here you have a data set. So these are the normal points we have, right? And one or two outliers we have. Okay, so now when I give a less value for contamination parameter, okay, let us say I want 1% or 2% or 3%, a less value. Okay, now what it will do, it will find the score of all the data points. Okay, and it will check which data point in 2%. Okay, so first it will take the 2% of data points which has the negative scores, or which 2% of data points are far away from the other data points. Okay, so when I give 2%, let us assume that it has considered this one data point as the outlier. Now, if I increase this value, so if I increase this to, let's say 10%, now what it will do, it has to identify more number of points, because I have asked to take at least 10% from my data set. So now it will see what other data points are away from the rest of the data points. So here, if you see, this particular data point is away from here. So this data point is away, right? So now what it will do, when you increase the proportion, it will find more number of points. Okay, so which are the other data points next? Okay, which is away from the data set. So it will increase the number of outliers now. Okay, so you can change this value. Okay, So by visualizing this data set, I got to know that very less number of outliers are there in my data set. So based on that, based on my intuition, I am giving a value for this contamination. Okay. But if there are more outliers, when you visualize it, if you identify there could be more number of outliers, then you can just increase this and see whether you are able to get all the outliers, or whether it is considering the normal data point as well. So you can change this value. You can do the tuning. Okay, you can adjust the values here and see whether you are able to get the outliers. Okay, so in this particular value, you are going to tell how much proportion of outlier can be considered in the data set. Okay, is it clear? So when you increase this, it will get more number of outliers. Okay, whichever is the next data point which is staying away from the rest of the data set. So those points will also be taken as the outlier. If you increase it to 50%, what will happen? It will take 50% of data points which are away from the, which are staying away. Okay, so you can increase this or decrease this and see how it is detecting the outliers. Okay, so we always assume that we have very less number of outliers. Okay, it could be 5% in less than 5%, 50%, right? So here the contamination value you can give in between 0.0 and 0.5. It cannot exceed more than this. Okay. So here I know that by visualizing I have only few outliers. Okay. So basically whatever outliers it has identified with the contamination of 10% is not the correct value, right? The number of outliers here is not correct. So let me change it to the same value which I have given before. So again, I'm initializing the model with the contamination value as 3%. So this predict function will tell me which data point is a normal data point and which is an anomalous point. Okay, so whichever has the -1, okay, that is defined as the anomalous data point. Okay, so this is how you can use isolation forest, okay, for identifying the outliers. Okay, so after this, what you can do? So once you detect the outliers, you can treat the outliers. Either you can go for if the outlier is very less, you can remove, but always removing should be the last option. Okay, so you can impute it with mean, median, mode. You can do the imputation like that, or you can go for several other techniques for handling the outliers. Right? So any doubt till here? Let me toggle this. Okay. So now let us see how much percentage of data has been taken as the outlier. Okay. So here, this is going to give me only the outlier data points. So here what I'm saying, I am selecting the records which has anomaly as -1. So these two records, these two observations has anomaly score as anomaly as -1. This is the score we have calculated from the decision function, and these two observations are the outliers. Right? So let us see how much percentage of outlier we have detected. Okay. So from the data, here I am calculating the percentage. How usually we will calculate the percentage? Number of outliers divided by total number of data into 100, right? So the len function will give me the count of records I have as the outlier. So these two records we have. So here it will be 2 divided by the total number of records is 50, right? So 2 divided by 50 into 100. So that will give me the percentage. It tells that 4% of data has been 4% of data has been detected as the outlier. Okay. So since this is an unsupervised learning technique, we don't have any proper evaluation metrics to evaluate this isolation forest. Okay. So you can just take the accuracy of this model. So again, like here, I'm taking all the outliers. Okay. So I know from this data set, whichever is greater than 1000, I'm going to take it as outliers. So first, let me take the outliers manually. Okay. So how I'm taking this manually? I'm going to select the records which are greater than 1000, which has the value as greater than 1000 in marks feature, right? So those records are going to be the outliers. Okay. So I'm going to get the count of the records which has the value as greater than 1000. Okay. So if you check the total outliers, we have 2 records. Okay, this I have done manually, right? And let us check how the model has predicted. So we got 2 records only, right? 2 records as the outlier. So we are getting accuracy of 100%. So how I'm doing it? So 100 into list of whatever records has -1 as value, right? So it is going to get the count of the records which got -1. So only 2 records got value as -1. So that I'm going to get divided by total number of outliers. Again, it's calculating percentage only, right? The same way I'm calculating the percentage here. Okay. So 2 divided by total number of outliers is 2 again, right? So into 100. So that will give me 100%. Because the total outliers we have is 2 and the model detected records is also 2. So we have achieved 100% of accuracy for this model. Okay. So how we are implementing the model? So you have to import it from ensemble module, which is there in sklearn library. Okay. So after importing, you can initialize it by giving certain values for the parameters. You can try with all other parameters also. So here, these are the important parameters which we have taken. Okay. So with this, we are building the model and we are training the model with the data. Okay. And this decision. So once it got trained, okay, we are going to calculate the score using this decision function. It will tell us what score each data point has scored. Okay. So this is a score that each data point has got. Sorry. Okay. So based on this score, the predict function is going to tell us which data point is an anomalous point and which data point is a normal data point. So when you call this predict function for your model, it is going to tell you, okay, which data point is an anomalous point. So when this it gets -1, any data point gets -1, then that is considered as the anomalous data point. Okay, and if it is 1, it is a normal data point. Okay, so this is how you can identify the outliers using isolation forest. Okay. So this is much easier when compared to other techniques. Okay, so usually we will go for z-score, or we will go for IQR range for checking the outliers, right? So this is much easier, when compared to those techniques. Okay, and here if you see, this isolation forest is not going to calculate the distance, right? Usually what we will do when we want to differentiate any data point from others, we will calculate the distance, right, to see whether that data point is similar to the other data points or not. If it is differing, if it is having more distance from other data points, we can consider that as an outlier. But here this particular algorithm is not calculating the distance, or it is not checking the density. Okay, it is only calculating the path length, and based on the path length, it is going to give you score for each data point, and based on the score, it is going to identify each data point as an anomalous point or as an outlier. Okay, yeah, it is an unsupervised machine learning technique. So here we are not giving any labels, right? We are just giving the data set and asking the model to identify whether it is an outlier or not. So model is going to do that. So this is an unsupervised learning technique. Okay, you can ask all your doubts. Okay, so if we give as auto, it is going to check how much percentage can be taken. By just looking into the data, it is going to decide how much it can take, how much proportion it can take. Yes, you can use isolation forest for detecting multivariate. Yes, you can use it for multivariate time series data set as well. Where the data set is sample. Whatever data set we are dealing with is a sample data set only. Okay, and while giving to each decision tree, it is going to randomly pick some samples and will pass it to each decision tree. Yeah, you will get the recording. You have to send a mail requesting for the recording. Nazim, if when you use predict function, okay, it will give you the value as 1 and -1. So 1 will be considered as the normal data point and -1 will be taken as the abnormal data point. So creates multiple decision trees and chooses a maximum value from T. So based on the path length only, it is going to get the score. Okay, based on the path length taken by each data point, the score will be given. Okay. Any other doubts? Yes, Basavaraj. Sorry, Shubhangi, you want to say something? Yes, Basavaraj.
Can you hear me, madam?
Yeah.
Based on the decisions tree, we have a condition only the outlier will get, right? So for example, you took the number of trees, it will be greater than 50. Whatever the data points, it will get greater than 50. Based on the path length, we identify that should be outlier, right?
Yes.
So when we come to the visualization part, in that one, it is based on the mean value. Okay, so which is the correct way to detect the outlier? So it is the and also which are the scenarios are to be to apply for this method for isolation forest?
Isolation forest you can use for any data set, for any problem to identify the outlier. Okay, so as you asked, like how the data point will be considered as the outlier. So here, for each decision tree,
Okay.
so it is going to have 100 decision trees, right?
Yeah. Yes.
So in each decision tree, it might take, the data points will be isolated in different path length,
Yeah.
right?
Yes. Yes.
So it is going to get the average.
So yeah, it's mean value. Mean.
Yes. So let's say we have 3 decision trees here. So like this, you have 3 decision trees where it is going to isolate each data point.
Yes.
So here it will see the path length of this particular data point, right?
So for
here
that one, yeah.
Yeah.
Okay, for that one, there are some of them are path length, or it is to be how we can detect it is a for example.
Yeah, I'm coming to that point.
Yeah.
So each decision tree is going to randomly pick some feature, right?
Okay. Okay.
So same way here also it is going to randomly pick some feature. Here it is going to randomly pick some feature. So it might be different features. So for each data point, it might take different path length to get isolated, right? Now, let us say here for this particular data point, it takes only one split. Okay,
Yes.
it takes one split here. And the same data point here might take 2 splits, okay?
Okay.
When we take a different feature, okay? The same way here, when we take a different feature, okay, it might, the same data point might take different path length to get it isolated, right?
Yes.
Now
Yes.
what will happen? It will take the average of this. Okay. So here it is going to take the average of all the data points. Okay. The path length of all the data points will be taken. Okay. So it's for normal data point, the average value will be more, right? When compared to the point which is outlier.
Yes.
Right. So
yes.
whichever, if I say a new data point I'm going to give, okay, I'm going to ask this model to predict whether this data point will be an outlier or not. Yes. So now what it will do, this algorithm is going to take this data point, it will do the split in the same way, and it will check the average value, average path length taken by this particular data point.
Okay.
If it is closer to the average value of a normal data point, it will be taken as a normal data point. If it is closer to the average value of an isolated point, okay,
yeah.
If it has very less number of split, okay, then it will be considered as an outlier.
Okay, and one more thing, which it can be used for any decision tree, right? Sorry, any model, right? ML model. So when we working on the linear regression or logistic regression and some more algorithms, we use somewhat we use taken for the mean value as a reference to consider to be a point or data point should be outlier or not. So how we can use based on the conditions, we can make the it should be outlier or not. Maybe it depends on the what decisions or what considerations we can take. It depends on the data set, correct?
Yes. See, when you will do this outlier detection, at which stage it comes in your project?
So after missing values in feature engineering, so the
it comes under feature engineering, right?
Yes. Yes.
So before creating the model, so for any model, okay, whatever problem you are dealing with, whatever algorithms you are going to choose, it doesn't matter. This comes under pre-processing stage, right?
Yes.
So you can implement this for any kind of problem, for any kind of data set. So this is only going to identify the outlier. So after that, you will decide how to handle the outlier.
Yes,
right?
yes, yes.
Then you
Yes.
will go with your normal stages.
Yes, yes, yes.
Yeah, this will be under feature engineering.
Picture. Yes.
Yes.
Thank you.
Yeah. Yes, Neha.
Hello.
Yeah. Hi.
Yeah, ma'am, actually, I want to know like box plot is used to visualize number of outliers, right? So,
Yes.
ma'am, if I'll use for multivariate data set, so, ma'am, when I used it, it was coming like it was very hodgepodge graph, like one above the another box plot was coming. So, there is any visualized technique for multivariate data?
You can go for scatter plot. That will show you, you can have multiple variables, two variables you can take and you can plot it, right?
Okay,
You can,
scatter.
yeah, for visualizing, you can explore on, see if any other, ways are there for visualizing a multivariate outlier.
Uh-huh.
Yeah.
Okay,
So here
okay, sure.
using machine learning algorithm, we are doing it. We are
Okay,
detecting.
sure, sure.
Yeah.
Okay. So, ma'am, is anomaly and outlier detection a same thing? Because on
Yes, yes.
internet, if we'll search, it will like,
It's
okay,
same only. We usually use it interchangeably.
okay. So, ma'am, this is only to detect outliers, not to
Yes.
handle, means how
No.
to like what to do with outliers. Then this is different thing, right?
Yes, yes. This helps only in detecting the outlier.
Okay, okay, ma'am. Okay,
Yeah.
okay. Thank you, ma'am.
Yeah. Okay. So any other doubts? Yes, Neha. Anomaly detection and outlier detection is same.
Yes, Kalpana, we have taken all the doubts now. So thank you so much for this wonderful session. I hope, guys, you got knowledge and in-depth intuition how the isolation forest works. So I have shared you the material link for this notebook, right? So do apply all these techniques on your data sets. Okay, now coming to the recording part, right? You can request to care@datamites.com for the recording of the session, right? And as well as for the material. Okay, and before to this, we have also done a session on missing values and how to handle the outlier. Basically, this session was detection. We have discussed few techniques how to handle the outliers. So you can check that as well. You can get the access for that videos as well. So thank you so much for joining the session, right? And yes, and any questions, anything you have, just post it on type. Kalpana and me will help you out.
Yeah. Thank you, Shubhangi, and thank you everyone for listening patiently. And thanks for the opportunity.